In 1998, BC 83, we have the Taylor series for natural log of x centered at x equals 1 is given by the series there. We want to let f be the function given by the sum of the first three non-zero terms of this series. So let's do that first. F of x is the first term, n is equal to 1, so the -1 factor will become positive there, and we'll get x minus 1 to the first power over 1. When n is equal to 2, -1 to the n plus 1 will become negative, and we'll get x minus 1 to the second power over 2. Third term, x minus 1 to the third power over 3. So we have the first three terms, and we're going to let that equal this function f of x. Now f of x is not exactly equivalent to natural log of x, but it is an approximation of f of x. If we use an infinite number of terms, we'd exactly have f of x. So we have this simple three-term function that approximates ln of x. Now, the next thing that we're asked is the maximum value of the absolute value of ln of x minus f of x is what? Well, ln of x minus f of x is just the difference between the actual function values and the estimates of the function values. And when we wrap that in absolute values, we're saying we don't care whether the difference is positive or negative. We're only concerned about the magnitude of the difference between the actual and the estimate. So when we're working with series, this is a very common and a very important expression, absolute value of the actual minus the estimate, or it could be the absolute value of the estimate minus the actual. Either one is this, they're both the same thing. Now normally we don't know what that error or what that difference will be. We can use error bounds either with an alternating series remainder theorem, or we can use the Taylor series remainder theorem. But in this case we have a graphing calculator, and we can actually graph the difference of these two functions and see on a given interval where the difference will be a maximum. And that's what we're going to do here. And so I bring up the graphing calculator, and I'm going to put in f of x by itself first. So that's x minus 1. I put it into y2, that doesn't really matter. Minus x minus 1 to the second power divided by 2 plus x minus 1 to the third power divided by 3. So that is, let's just double check, x minus 1 minus x minus 1 to the second over 2 plus x minus 1 to the third over 3. Alright, then in y1 I will then put in my absolute value, math, number, absolute value of natural log of x minus my new function vars, y vars, function y2 in this case. I'm going to turn off the second function, turn it off from displaying anyway, and I want to graph now the absolute value of natural log of x minus f of x, and I'm going to set my window to go from 0.3 to 1.7 by 0.1 and have the y values. Now if you look at the answers there, the differences are pretty small, less than 1, so we can actually have the y values only go up to 1 by 0.1 as well. And we'll graph that and take a look at it. And you can see in there, on that interval, the highest point definitely is over at the left endpoint there, and that would be at 0.3. So we can do second calc and find the value at x equals 0.3, and it says that it's 0.1446, which rounded to 3 decimal places is 0.145. And so that's going to do it for this particular problem. So we used a graph to find the maximum value of that expression on the closed interval from 0.3 to 1.7.